Hi, my name is Saswat. Currently, I am studying in class 9 at DAVSCB. Today, I will be reading about a very interesting topic, which is about nanotechnology. So let's read. Nanotechnology is the engineering of tiny machines. This is done inside personal nanofactories using technique and tools being developed today and make advanced products. Nanotechnology is the technology of future and it will aid in a manufacturing revolution. A nanometer one of uh, is 1 billionth of meter, probably the width of 3 or 4 atoms. A human hair is about 25,000 nanometers wide. So one can imagine how small these machines will be. The development and progress in artificial intelligence and molecular technology have spawned this new form of technology. Background of nanotechnology. The idea and concepts behind nanoscience and nanotechnology started with the talk entitled "There is a plenty of room at the bottom" by physicist Richard Feynman at an American Physical Society meeting at California Institute of Technology, Caltech, on 29th December 1959. In his talk, Phenomenon described a process in which scientists would be able to manipulate and control individuals' atoms and molecules. Over a decade later, in his exploration of ultra precision machining, Professor Norio Tanguchi coined the term nanotechnology. It wasn't until 1981 the development of scanning tunneling microscope that could see individual atoms that modern nanotechnology began. Impact of nanotechnology. Nanotechnology is sometimes called a general purpose technology because in its advanced form it will have significant impact on almost all industries and all areas of society. It will help in creating better built, longer lasting, cleaner, safer and smarter products for the home communication, medicine, transportation, agriculture and for industry in general. It is more than just mixing nanoscale materials together. It requires the ability to understand and to precisely manipulate and control those materials in useful way. Nanotechnology involves a new and broad science where diverse fields such as physics, chemistry, biology, material science, and engineering coverage at the nanoscale. It is also important to understand that nanoscale materials are found in nature. For instance, hemoglobin, the oxygen transporting protein found in red blood cells in 5.5 nanometer in diameter. Naturally occurring nanomaterials exist all around us, such as smoke from fire, volcanic ash, and sea spray. Some nanomaterials are byproduct of human activity such as bus, automobile exhaust and welding fumes. Implication of nanotechnology. To understand its implications, try to imagine a medical device that roams through the human body to find and destroy tiny clusters of cancerous cells before they can spread. Another example is a box of size of sugar cube that holds the entire content of public library or material or materials 10 times lighter than steel yet 10 times stronger. Nanotechnology will be uh, Nanotechnology will result in greatly improved efficiency in almost every aspect of life as has been mentioned above. You may recall of the size of nanoscale page that nanoscale is about 1 to 100 nanometers. Working at the nanoscale requires an understanding of the various types and dimensions of nanoscale materials. Different types of nanomaterials are named for the individual shapes and dimensions. Think of these types such as particles, cubes, wire, films, flakes, or cells that have one or more nanometer size dimension. For example, carbon nanotubes have a diameter in the nanoscale but can be several hundred nanometers long or even longer. Nanofilms or nanoplates have a thickness in the nanoscale but their other two dimensions can be much larger. The key is to be able to both see and manipulate nanomaterials in order to take advantage of their spatial properties. As mentioned earlier, the invention of spatial microscope have gave scientists the ability to work at nanoscales. The first the first of these new discoveries was scanning tunneling microscope. While it is mainly designed to measure objects, it can also move tiny objects such as carbon nanotubes. People are doing many different types of work in the field of nanotechnology. Most currently work looks at making nanoparticles that have special properties such as the way they scatter light, absorb X-rays, transport electrical current or heat, etc. At more science fiction end of the field are attempts to make small copies of bigger machines or really new ideas of structure that make themselves. New materials are possible with nano size structure, and it is even possible to work with single atoms. Nanotechnology development in India. The nanotechnology initiative in India is a multi-agency effort. The key agencies that have taken major initiative for capacity building are the Department of Science and Technology, the Department of Information Technology, and other agencies that have shown major involvement in the field of nanotechnology are Department of Biotechnology, Council of Scientific and Industrial Research. In addition to this, nanotechnology as a distinctive area of research was started with Nano Science and Technology Initiative. In 10th 5-year plan, some of the major initiatives in nanotechnology are launch of nano mission and introduction of PG programs. In nanoscience and technology, nanotechnology intervention in mission mode was introduced in the field of solar and water technology. Conclusion: nanotechnology will have both commercial and military uses. It can be used to create powerful weapons and tools for surveillance. So it comes with benefit and risk. It implies not just better products but a much improved manufacturing process. With nanotech, building products become as cheap as copying of files on a computer. This explains why it is sometimes seen as the next industrial revolution. The technology could give the human race eternal life or it could cause complete destruction. That's it for today. Thank you and have a nice day.